Title of today's presentation, Taking Your SOLIDWORKS CAM to the Next Level with GoEngineer. I'm Robert French. I'm an applications engineer at GoEngineer. Kim Rogers is one of our SOLIDWORKS CAM and CAMWorks sales rep. She'll be joining this call shortly, but let's go ahead and get started. So just a quick recap, a few minutes, just talking about GoEngineer as a whole. We spread across the country quite a bit in the last few years. You can see we've got offices pretty much going coast to coast now. It's great for our customers, support everywhere, in-classroom training everywhere, on-site support everywhere, so real nice to see. Just our mission statement, you know, we're here with all kinds of technologies, all kinds of capabilities. We have the experts to back it up, help you guys get what you need to get done, right? So we're always bringing on new products. We're always out there hunting the market for the tools that you all need to be successful. A couple expanded services. We've always had our classroom training. Definitely online training has taken off in the last few years. We've got a couple more online resources now. Abilities on our website to schedule time with application engineers like myself. We have self-paced training. A lot of different offerings out there. Contact your local sales rep. They'll be happy to let you know everything we're trying to offer you. Tech support always still available. 3D printing's really taking off. I'm actually moving on to that team, taking on some new roles there. We've got some great new technologies coming with Velo 3D, some new metal printers, things like that. And we're always happy to offer our printers up as a job shop for you guys to get your parts printed and try out try out 3D printing without making that big leap initially. So all right, so let's jump into the CAM side of things. So talking about the next level, right? SOLIDWORKS CAM, which if you're an active SOLIDWORKS user, you currently have SOLIDWORKS CAM, but why might you want to jump that up to the next level, right? To these additional packages, higher level packages that offer more functionality, right? So typical questions we might ask ourselves is, you know, are we looking for better surface finish on our parts? Do we want higher quality parts made? Do we want to take more advantage of our machine with more sophisticated toolpaths and get higher throughput, right? And is our machine even capable of taking on these more advanced toolpaths and more advanced functionality? So here's our full breakdown of the SOLIDWORKS CAM and CAMWorks packages. Now, sometimes people get this confused about, hey, I see SOLIDWORKS CAM Standard and SOLIDWORKS CAM Professional. Well, is that like SOLIDWORKS Standard and SOLIDWORKS Professional? I have those licenses matching what I have as a SOLIDWORKS license? And the short answer is no. You all have the first column there, SOLIDWORKS CAM Standard. Any license of SOLIDWORKS on subscription has access to that first column. Every package above that is a upgrade. Now, the naming convention, SOLIDWORKS CAM versus CAMWorks, is not significant. It's just SOLIDWORKS recently licensed some of the CAMWorks software and kind of branded it themselves, but this is a very linear upgrade path. It's all the same software, just has a name change once you hit a certain level. It's only a name change. Can't stress that enough. All right, so let's start with our first package here. What do you all have access to? So SOLIDWORKS CAM Standard gives us full prismatic feature programming. So prismatic features being flat-bottomed features, holes, pockets, slots, bosses, face features. Your nice kind of simple blocks, Lego block parts, if you will. And we also do get some limited multi-surface feature programming as well. And that comes in the form of, as you can see, the Z-level toolpath. Let's jump over to the software and take a look at SOLIDWORKS CAM. All right, so here in software, I'm in the CAMWorks environment right away when I'm in SOLIDWORKS environment. It's one software in the same. That's a huge advantage just to start. We don't have to export some kind of CAD neutral file format like a STEP or an IGES. Everything's self-contained right here inside of SOLIDWORKS, and that gives us all kinds of advantages. So when we turn on the SOLIDWORKS CAM add-in, mine happens to say CAMWorks 2021. Once again, same software. Interface will be identical. We get 3 additional tabs in the Tree Manager area, starting with the CAMWorks Feature tab, then we have the CAMWorks Operation tab, and then we have the CAMWorks Tool Tree. We also get some additional Command Manager tabs up top to help organize and manage our different commands that we can execute inside the CAMWorks environment. So just a quick breakdown, and it's going to be brief. I apologize. We have a lot of videos that cover all these topics more in depth on our YouTube. I'll actually show you a few of those later. But keeping it brief so we can get through the 30 minutes today. Our first step in CAMWorks is always to recognize features. It's a feature-based CAM software. It's analyzing geometry intelligently, looking at the difference between your stock and your final part. So we can see my kind of square stock outline out here. And already in my feature tree, I've created a couple of setups. Now these setups, when I highlight them, kind of show you an arrow on the screen. What direction does the tool expect to come? So on a vertical milling machine, part would be oriented in this direction and give our tool access from that orientation as well. So within that setup, I've created 2 features, a face feature and an open pocket with a boss located in the middle. So CAMWorks is fully capable of recognizing some of these 2.5 axis, or all 2.5 axis features, I should say, automatically. In fact, I'll delete this face feature. Let's jump into my CAMWorks options real quick. And I'm just going to give it the ability to recognize face features only. Back here in software, within that setup, I can right-click it, ask it to recognize features, and it's able to find that face feature automatically. So that would work great on all 2.5 axis parts, all 2-axis turn parts. But this part gets a little bit more sophisticated. I've went ahead and created a somewhat complex wrapped feature, as we might call it, on this part that I'll have to recognize manually, and I'll show you that in a moment. But you can see how feature recognition on, even on a part like this, if it's complex, if I had holes scattered throughout this kind of wrapped feature, those would be picked up automatically. The next step after recognizing features is to create our operations. This is another thing that can be done automatically. You'll notice after each feature name, in this case the face feature, we see what we call a strategy. In this case it's finish. I can take advantage of these strategies. They're saved in a database. They're customizable. This is what really can help you speed up your programming. I say generate operation plan, and it goes ahead and spits out a face mill for me. It says you have a pre-described way of cutting this. Here it is, 1 click away. I don't have to spend time going through the multitude of settings for any operation. There's all kinds of different parameters I could change. At this time I could. Right now it's set to 10-degree cut angle. You can see that represented on screen. And maybe I don't need that. Maybe I just want to switch back to 0 degrees, keep it simple, update my toolpath. All right, now we're going straight. That's not a change I want to make every time. I can jump back to my feature, save that updated strategy. And now anytime in the future, I can prove it to you right now, if I go ahead and delete that face mill, I can regenerate the operation plan, extract my strategy once again. And when I do that, we see the toolpath back to that 0-degree angle. So that's a workflow that is present in all segments of the software, every package level, no matter how complex or simple the feature. And that's one of your biggest benefits. That and the integration, right? We're still inside of SOLIDWORKS that I spoke to earlier. Those 2 ideas right there alone are why CAMWorks really stands out. So looking at some of the toolpath we're able to create with our included package, back to our big picture of this webinar, what can I do with each package? Why should I consider going to the next level? All right, so we see some simple rough mills, contour mills, once again, what we call prismatic features, flat bottom features, right? That's taken care of real quick and easy. But now let's go back and talk about the multi-surface feature that I created a moment ago, or created earlier. This, we actually identify surfaces that we want to cut. With 2.5 axis features, It's a lot like an extrude or an extrude cut command out of SOLIDWORKS, where we draw a 2D profile and give it a depth. But here with multi-surface features, we're a lot more powerful, can choose directly on surfaces, and really choose some complex geometry to cut. Now, as far as the toolpaths that we can program on multi-surface features in our SOLIDWORKS CAM Standard package, we're going to be limited to what we call area clearance, really just a roughing cycle, hogging out as much material as we can. And that's in order to prep for a finishing pass. The only finishing pass we have available, as I mentioned earlier, is the Z level. It's pretty easy to understand how this works if we take a side perspective view. We're slicing the part with different Z planes. Where those planes intersect our surfaces, we're creating toolpaths. So this gets a pretty good surface finish in most areas, but in certain flat areas, it can tend to break down. Now, there's other steps I could take to get around this. For instance, the walls in this multi-surface feature, this wall particularly, the best thing we could do to get a good surface finish on that is line the end mill right up with it and do some true side end milling, right? Have this part oriented in a vise in this manner so that the end mill can come sweep right across that. I actually had a setup created. I guess I had it on the reverse side. But now you can see my tool orientation coming down. I've got an open profile feature created there. I could go ahead and program that. I have some lead in, lead outs that I could modify, make sure I'm not gouging. But that would get me the best surface finish there, but it'd be very difficult to orient the part in this orientation in a vise and really know that I'm lined up correctly. So I'm a little limited there. I could tweak and play all day with Z level, but it's a lot of headache, it's a lot of time spent, and at the end of the day, you're still not getting the surface finish you could by taking your SOLIDWORKS CAM to the next level. So let's jump over to SOLIDWORKS CAM Professional. So a lot of new modules, as we call them, available in this package level. We have 2-axis turning, right? So we're able to jump over onto our lathe machine now. We have volume mill, which is a roughing cycle. It's very high speed, has a lot of benefits like minimizing tool wear, maximizing throughput, very capable of cutting very, very hard and stubborn metals. We also have 3-axis milling level 1, right? So we're jumping up our 3-axis capabilities, our multi-surface feature capabilities. We only had Z level a moment ago, but now we're going to get a little bit more functionality, a little bit better surface finish. We don't have to finick around and do awkward things trying to achieve good results. The software is going to help us do that. We also get 4 and 5-axis indexing. We also have the advantage of programming our probes, right, to touch off on our part. Let's jump on to the next part here, SOLIDWORKS CAM Pro. So just talking about turning. Turning is, once again, something that happens very automatically, especially 2-axis turning. Automatic feature recognition, that ability to analyze our part and create our features for us. In fact, I'll go ahead and just delete this current setup I have, everything programmed, because with the ease of the use of the software, I can get back there within a few seconds. I'm going to go ahead and extract machinable features. We notice that we see the face feature out here on the front of the part. We see an OD feature, and it knows what the maximum OD is, right? It's not going to be where the flat on this little square peg is. It's going to be at one of these corner points where the radius is most extreme. That's the minimum turn profile that could be used to program this part. And we finally have a cutoff feature. Right, those are the only turn features present on this part. This multi-surface feature in the middle is not handleable, not doable on a lathe. Now, once again, I can get my toolpaths back very quick with Generate Operation Plan. These are customized strategies, once again, so I can have these all preset, programmed the way I like to do it, that I know is safe, effective, gives a good surface finish. Finally, generate toolpath for all that. We see that preview of toolpath on the screen with a face rough, face finish, some OD rough and finish. Another cool little feature that I always like to mention is, might be getting a little too close to our jaws here. Maybe we need a little bit more stock. Maybe we need to push the stock out a little bit. But one thing I recommend to all customers on the turning module is to make every one of your strategies use this option right here. Enable chuck fixture avoidance and establish a clearance value to the chuck fixture. So we see that arrow turn on. When I turn on that checkbox, it'll automatically curtail my toolpath, prevent it from running into my fixturing. Might as well go back and right away save that operation plan, make that a standard, right? There's no reason why that should never be checked on. So there's the turning module. Let's jump into our next example. One thing not mentioned in that picture breakdown within my PowerPoint is the ability to use fixturing, right? We can actually do assembly machining, bringing in our fixturing, modeling it all up, really understanding the context in which the part's going to be machined. So this is a part I already had programmed. Now that I've brought it into an assembly, I don't want to have to reprogram it. There's actually a great shortcut for that. I can import the part data, import the part program here into the assembly file with all the new context taken into account. So this isn't the exact same part, but it is another part file I had programmed. All I had programmed here was this multi-surface feature, none of the square peg programming. But I have that multi-surface feature program done. And I have two toolpaths over here, area clearance and Z level. Let's jump into area clearance, our roughing routine. And I have it set to volume mill. Once again, this is that high speed, great tool utilization, capable of taking on difficult materials toolpath. Doesn't look too much different than your average roughing routine, though the way in which the tool travels is a big part of this routine. So going around and roughing as much as it can. Let's take a look at the Z level as well. Previously, it was limited to the Z planes, as I had shown. But in this case, with the SOLIDWORKS CAM Professional license, we can enable this checkbox for combination cycle. It's going to be able to deviate from that Z restriction, Z plane restriction, and get you a much more comprehensive toolpath, more capable of some of the trouble geometry that, plagues the Z level toolpath. Still good, very powerful. There's still more advanced toolpaths. This one is a little limited. These are all the options for it down in this bottom left corner of my parameters window. So even though it does gain you a lot of great advantages, there's still even more advanced 3-axis toolpaths that are really worth considering if surface finish throughput, right? All these ideas are really at the forefront of your goals. There's still plenty of reason to look at these other 3-axis toolpaths. Now, one other thing, though, is, well, it's great that we have assembly mode, but we're still running into our fixturing. I can jump in, edit my setup, and indicate what fixtures are present, indicate that I want to avoid all of them. Now every toolpath within this setup understands the fixturing involved. Every toolpath will adjust and update and no longer crash into my fixturing. So one huge advantage if you're using complex fixturing, vices, things like that, jumping up to SOLIDWORKS CAM Pro for the assembly capabilities can really help you prevent crashing your machine. Last idea here that I just wanted to review was the indexing capabilities. You can see in my CAMWorks feature tree, I have my machine set to 4-axis. I've established a coordinate system and indicated where my rotary axis happens to be. So I have this rectangular corner slot already programmed, rough mill and contour mill. Now, if I didn't have indexing capabilities, it would be a manual refixturing. I'd have to walk out to the machine, unvise it, rotate it, retouch off, or vise it down, retouch off, right? Reestablish all my work offsets and things like that. And that can get a little bit painful. So instead, I just have my machine set to 4-axis, have my rotary axis established, and go ahead and program the next feature in that setup. Now, if we look at the setups on the operations tab, if we look in the first one under our indexing tab, we're at the 0-degree rotary position. Whereas if I jump to the second setup, we have 2 options. We could rotate 270 degrees forward or -90 backwards, right? So reducing the number of times you need to fixture your part is time saved to you. It's higher quality parts. Every time you have to retouch off on a part, you risk the shifting of the part. You're adding tolerance stack up. So definitely, if you have a machine with indexing, very much worth considering the SOLIDWORKS CAM Professional package. Let's move on. Definitely got to speed up here. So CAMWorks Standard, our first CAMWorks package, adds 2 main functionalities. It's the sub-spindle operations. If you have a lathe with a sub-spindle, you'll get the sub-spindle operation parameter manager. That's a mouthful. But what this basically allows you to do is strategies, right? It's a big theme inside of CAMWorks is create a strategy for how the sub-spindle engages. It rapids over to within a certain distance of the part, slows down to a feed rate, it clamps, the main spindle unclamps, the sub-spindle retracts. You can set up all these routines as saved strategies and efficiently program your parts. Once again, keep you off the machine, keep the machine running, doing its thing, automated, and right, throughput goes up. We also have rotary milling. So this is for machines that have mill machines that have a 4th axis. So in this case, I do still have it. Right, if we had a machine resting on a part resting on the table with this 4th axis rotary head with our part mounted on it, gives us a lot more advantage to programming this part. Let's hide that though once again. So this basically allows the functionality in CAMWorks of what we call wrapped features. Similar to 2.5-axis features, I can choose a profile. Remember I said 2.5-axis features are like a boss extrude or a cut extrude. We choose a 2D profile and give it a depth. Similar idea here. I can choose a profile. In this case, I'll just choose the face, and I'm choosing the edges of that face. And now I'll give it a depth. All right, I can set that depth arbitrarily with a number value, but one of the best things we can do because we're inside of SOLIDWORKS is I'm just going to click the OD of my part, and it sets the height of the feature there. It's an up to face end condition. If this part were to grow and morph on the design side, I'm linked to the faces on the CAM side. So wherever those faces go, my CAMWorks features go and my toolpaths update. Huge advantage to the integrated package. So program it just like normal, generate operation plan, spitting out some toolpaths. One limitation of the rotary milling is that the tool must be pointed at the center of rotation. All right, jumping back. Next level up, CAMWorks Milling Standard. This is when we really unlock the majority of 3-axis capabilities. And that's pretty much the entire list there on the left. They're not all separate items. They're all part of one family, which is these are all the great new 3-axis toolpaths that you get access to. Pattern project, constant step over, pencil milling, curve project, and the legacy toolpaths from older versions of CAMWorks as well. So once again, all I have programmed is this multi-surface feature, just the insides now. I have a simple area clearance going in there to hog out a majority of the material. And I'm going in with a couple different pattern projects. And I have several different pattern projects here because it's one of my favorite toolpaths. It has a lot of flexibility, a lot of easy to understand and very effective options that you can really understand with just 10 minutes of use. You can see all the different benefits of them. This first pattern project, just slice. This second pattern project is what we call my point shifted on me, but it's what we call a radial toolpath. There's a center point somewhere out here where the toolpath is radially projecting from it. This is a spiral toolpath, same idea, with the point somewhere over here to the right of my part. We're doing spirals outward and kind of see the arcs of those lines. And then we lastly have what we call, it's my favorite, it's using the curves of the part, using the geometry of the part through what they call flow line. I can actually determine curves to follow along. In this case, I chose the two ends, two left and right ends. You can see how the curve kind of matches those left and right edges, and they slowly morph between one another as they travel from left to right. We have constant step over. This is your most comprehensive toolpath. It doesn't mean that it's always the one you want to go to. Z level definitely has its place. Pattern project definitely has its place. They're a little bit easier to control. Constant step over really tries to hit everything the same way, right? It's a constant step over no matter where the toolpath goes. But it's a little harder to control in some cases and might be overkill. So pattern project and Z level still have their place. There's also pencil mill, another really good one for getting good surface finish, good final parts. Its whole job is to just tuck into the corners, the sharpest places, the tightest places, and focus on those areas only. All of these toolpaths are created off of that same set of features, which I can highlight real quick to make clear. Right, but all the generic 3-axis finishing toolpaths and roughing toolpaths pretty much go everywhere, but you can see that pencil mill doesn't care about all the flat, broad surfaces. It's just worried about sharper corners. I have a full video breakdown of these toolpaths on our YouTube page. I actually made the video myself, right? SOLIDWORKS CAM and CAMWorks 3-axis operations. This is a very comprehensive breakdown and really goes into the fundamentals of how the toolpaths are applied. So if you're interested in these toolpaths or these higher level packages, this is a really good place to start. With CAMWorks Turning Standard, we really just access the ability to program mill turn machines. Turn machines that have live tooling or, basically a mill head, right, able to rotate the tool present on your turn machine. Now, there's not much of an example in software for that. I'll just show you that the environment, as you can see on the left-hand side of my screen in my operations tree, has a turn setup present and a mill part setup present, right? So all of that functionality, all available in one place. Do a quick simulation. Not too fast, maybe. Some OD treating. Now we're into mill programming, right? Treating up those slots. And then we go back to turn programming right at the end. If it goes quick enough, I might stop it. We're going to go back to turn programming right at the end. We're going to do our cutoff feature. Well, maybe we'll skip that. Nobody wants to watch the toolpath go forever, but we can come to my final setup where the last operation here was to come and cut the part off. Now, quick error message that showed up there. Another great benefit of the software is having this in-software simulation where we can detect collisions between our tools, our parts, our holders, things like that, and be alerted to it. So protect ourselves out on the machine. Next column over is CAMWorks Milling Professional. I don't have anything in software here. I was trying to make a part that could kind of show off everything. A little difficult, right, and gets a little unrealistic, but CAMWorks Milling Professional unlocks the absolute tip top of the 3-axis programming. It basically allows for undercutting. I say not keyways. What I mean by that is keyways were programmable back in the first package, right? And what we mean by undercutting is, as you can see in the picture on the left there, there's a section of the tool that cuts above kind of that halfway point where the tool face is actually looking upward, looking in the negative Z direction on our tool. So you're cutting these multi-surface features that are, the surface themselves would be kind of facing downward on the part, right? So you're using the top edge of that tool. Next package up, Turning Professional. We have what we call synchronous machining unlocked, or otherwise known as pinch turning, a very efficient tool path, very efficient way of cutting. You have to have what we call what is called a dual turret machine. Tools are mounted on the turret in a lathe. They're usually mounted up and behind. On more advanced lathes, you have a secondary turret. In some cases, other turrets. You can have more than 2 turrets, but you can have another turret mounted down below, kind of in the front of the machine, near your feet. You'd have one tool, perhaps loaded in the upper turret, doing a roughing pass, and just behind it, on the bottom side, the secondary turret is following with the finishing pass. Does a lot of stuff, not just saving time, but your part's a lot more stable, being cantilevered out, because you're pushing from both sides. You're not deflecting your part at all, so quality can go up quite a bit as well. Another thing offered by Turning Professional. I know we're over time, guys. I appreciate you all sticking with me. I'm very close to the end here. I'm running as fast as I can. Another thing available here at the Turning Professional level is the Machine Simulator, or Virtual Machine Standard, which is a simulator. Now, it takes a long time to set up. I don't have a great example of it now, but I can speak to it in this case, which is we're able to take our program and pump it out to a third-party software. This third-party software is even more sophisticated than our in-software simulation. This isn't the exact software, though it's very analogous, that I'm pulling up currently. What really separates it is we're including all parts of our machine. Everything's involved. And the other big benefit, it's really the crucial benefit, is when we're in software, our simulation there is just a tool following a line on the screen. Nothing too complicated. But in the virtual machine simulator, we're actually using the G code that we post. We're taking G code, posting it out, and using that to run the simulator. And so that's a much more comprehensive check of your entire programming workflow, right? Because you're taking into account, is your post set correctly, or all your G codes and M codes and stuff configured correctly? And the virtual machine simulator is going to utilize all that information and give you the most accurate and comprehensive simulation possible. Our final column here, it's the cream of the crop, right? It's the top tier. It's CAMWorks Premium. You can see the check marks run top to bottom. We're going to get everything we just talked about in every package before. And the real cherry on top is that we finally get full 5-axis capabilities. We're able to use a 5-axis machine and utilize all 5 of those axes simultaneously. Just contrast that real quickly with 4- and 5-axis indexing, where you do have a 5-axis machine, but you're only using that 4th and 5th axis for positioning the part, indexing the part. You're never using all 5 axes simultaneously. There we go. So into our CAMWorks Premium part file, where this guy, we've gotten it pretty good in a couple different package levels, right? Where we found a couple various enhancements and different toolpaths that could cut this. But as I stated earlier, the real way to cut this part would line the tool up right next to these surfaces. Use the true side end milling to go around and cut all of those. That uses a new operation, which we call the multi-axis mill. It can be a 3, 4, and 5-axis mill toolpath. We're going to use it here full 5-axis. Just real quickly jumping into the parameters for it. It is a complex tool. It's a sophisticated tool. There's a lot more going on. There's all kinds of new settings, new tabs, lots of parameters going on. You're still able to save a strategy with it, just like any other section of the software. I actually, once again, have another video, Introduction to 5-Axis Programming, on our YouTube channel. Tries to give a good comprehensive look at the tool, though you could spend hours and hours on it. But I really just try to teach you, point out the key tabs, the key parameters that you're really going to want to focus on for an effective toolpath. So another great video to start with if you're looking into the 5-axis programming world. But just running the simulation of this guy real quick. If I were to simulate this, I'm not going to have the area clearance done first. I don't want to make you guys watch the area clearance. So I'm going to use a little trick here is before I click simulate, I hold down my shift key. And what that does is starts the simulation from a work in progress, WIP. I'm going to say start this simulation as if the area clearance is already cut. All right, so we start in a much better place to really observe what this toolpath is going to do. Try to give you guys some perspective of the full 5-axis motion of this tool coming in. So obviously X, Y, and Z axes are moving, and you can see the tilt in both the A and B directions, utilizing our 5-axis, I should say. And you're getting that real good finish. Obviously, in our simulation, we can do a comparator. Green meaning on size, blue meaning undercut. But we can see those walls are getting hit right on the money. Best way possible. Best surface finish. That's our full 5-axis programming. Ooh, let's jump to here. Now we have a couple other bundle add-ins that we're not going to go through today. But you can see like synchronous machining for lathes and the virtual machine standard and 4-axis milling. So simultaneous 4-axis are all extra add-ins you can throw in as well. We also have another product called Nesting Works. If you're cutting lots of sheet metal or wood panels and things like that, you want to optimize your sheet usage. Nesting Works is a great tool that works hand in hand with CAMWorks as well. Just some of our social media presence. We got a GoEngineer newsletter, keep you abreast of all the new technology, changes happening. We'd like to keep you guys informed. I mentioned all of our training options earlier as well. We have our YouTube channel, which I just shamelessly plugged myself twice on. I got a couple other videos up there as well. Hopefully you guys find them useful. We're on all the major social medias as well, so look out for us. And yeah, just our mission statement again. We're here to help you. We got all kinds of cool technologies, cool stuff to help you. Lots of specialists, lots of experts to help you do it correctly and efficiently. So just reach out and let us know what we can do to help. And thank you all for coming.